Hey, welcome back everybody. Jeff Frick here, coming to you from the Baylands, one of my favorite places. I'm excited to release the second interview that we have from Humanoid Summit in collaboration with the team in Humanoid Summit and All Ventures. This is with Pete Florence. He is the co-founder and CEO of Generalist. And Generalist has something called Gen Zero. And Gen Zero, I'm just going to read it, is the embodied foundation model that scales with physical interaction. And Pete shared some really interesting slides during his keynote. The one that really got my attention is he was showing what happens with big models, and the ones he was talking about with 1 billion parameters. At a certain point, the model really stops reacting positively to more data and more training, and kind of does what they call kind of forcing it to fit in the model. Anyway, it stops scaling. And then
at 6
billion parameters, the model does a lot better. It gets further before it kind of stalls out, but ultimately it doesn't continue to get better and better with more data and more trainings. And then at 7 billion parameters, something kind of magical happened. It just kept getting better. So the more data, the more trials you pumped into the machine, the better and better it got across skills and behaviors. And that becomes pretty compelling, because if that's in fact the case, as Pete said, it doesn't even really matter what the X is, what the skill is, what the behavior is. If you can do more of it and you get better at it by doing more of it, the machine will also get better at doing everything else. If that's pretty amazing. I mean, that kind of stops you in your tracks, right? If that's in fact true. And we've gotten that big in terms of the number of parameters. The other thing that Pete talked about that I thought was pretty interesting was, kind of the generalist versus specialist discussion. And, the specialist robots have been winning for a long, long time. The generalists just weren't there. But his point was any specialty area eventually kind of expands beyond its bounds and gets bigger. And any generalist area is eventually going to come into whatever you thought was kind of a walled garden in your specialty area. And so what they decided to do is bet on the generalist. And he's been around long enough to know, and he's seen some things that if he's betting on generalist, he's got a pretty good feeling that it's just around the corner and not that far away. So without further ado, my interview with Pete. Thanks for watching. Thanks for listening. Bye-bye.
Let's go in 5, 4, 3.
Hey, welcome back everybody. Jeff Frick here, coming to you from the Computer History Museum. Our second trip back to Humanoid Summit. We were here a year ago, was the inaugural event, and I think I've heard it's gone up by a factor of 3. They had another one, I believe, in London last summer, and they just announced that they're going to be in Tokyo next summer. So, as Andre K says, humanoids are having a Cambrian moment, and the progress from just 12 months ago is pretty amazing. So we're excited to have our next guest. He's Pete Florence. He is the co-founder and CEO of Generalist. Pete, good to see you.
Good to see you. Thanks for having me.
Absolutely. So you've been in this space for a little while, and you've been in kind of deep research around AI and vision and voice and some of these things. So you've seen kind of this magic come to fruition. One of the big topics that always has been in the past is specialist versus generalist. And probably the most successful robots out there are maybe the vacuum cleaner or the little Amazon robots that are running around at scale. You decided to come out a pure generalist. Why do you want to tackle it that way?
It's a good question. I think for us, we really think that the huge untapped opportunity is in making robots that are extremely general purpose. At the same time, you do need to excel and be specialist enough at any one particular thing to actually make it sort of useful in the real world. But I think, the lessons of the last handful of years of machine learning have taught us that every time you try and think, I'm just going to have this narrow little model in this one little domain, and that's going to be my little niche, and then the general models will do other things but not my thing. That's not a bet long term that we think is the right one to take. And a lot of it just comes down to, it is the case, and part of what I talked about today with Gen Zero, we just see that all of the data makes everything better. And not just the data, but the way the models are trained. Once you sort of take the leap of faith that all of the tasks that you can possibly think of, trained all together, do indeed make the model better at all the individual little things, yeah, you want a general purpose system.
Right.
That said, today again, like it really matters to actually achieve a level of mastery on particular tasks to actually have them be like relevant for real use cases. But yeah, generalism the way to go for sure.
So, talk a little bit how LLMs change a game in terms of training and also just other foundational models, because it seems like there's a really big shift in the training, which is just one of many of the factors that's accelerated this whole thing. But it feels like the foundation models and the language models were really a big factor in bumping this thing up a step.
Yeah, 100%. There's many different ways to look at it. I mean, if you go back to before language models started to take off, and I haven't been around forever, but I've been around long enough that I remember well when people were starting to whisper that like, hey, these language models are starting to really work. And back in kind of like the mid-2010s, there was several different frontiers of deep learning that were all kind of happening in parallel. And I would say in the mid-2010s, vision was really the one that had the most kind of momentum. And it was only into, this is at least, from my memory and my own personal experience, but into the late 2010s, it started to be, okay, wow, these language models are really starting to work. And then once the sort of obvious implications, once everybody kind of let it sink in, like what GPT-3 and beyond were going to be capable of, then you started to see just like the entire way in which we train these models, the way we understand them, the way we do evaluations, this whole entire like maturation of the model factory, so to speak. A lot of the lessons and the way that we train those types of models, there's many different ways in which then they impact the way that we train robotics models today. Right. One is just kind of like taking a lot of different aspects of the general recipe and applying them completely separately in robotics. But then also too, and this is part of like a bunch of my work back at Google, is like literally taking the language model and also making it the robot brain, right? And once upon a time, not that long ago, it was a crazy idea to just like, okay, we're just going to take the language model and we're just going to train the language model itself to also be the robot model. But now, of course, that is sort of obviously a good idea. There's a lot of nuances in terms of things from there, but that is clearly, obviously a good idea now. Yeah.
Right. But I think it's the VLA, right? It's the vision, the language, and then taking action from that, which was really a revolutionary concept to combine those two.
I think in particular, a few years ago, it was just wild times in terms of so many different ways in which we could think about taking language models and using them in robotics, and it was also a time where all the labs were like publishing still pretty freely. It's different now. But it was very easy to come up with lots of different ideas, like, oh, we could do a language model this, language model that, and bring it into robotics. And you can have a lot of like kind of like agentic type systems where you can kind of design a way in which the language model kind of interacts with your robot. But ultimately, I do think that the most powerful way is to just take the language model and make sure it is a multimodal language model, which back at Google, like we actually had to, at that time, like, there was basically only one multimodal language model that existed before the one that we made back at Google, which is called Palmy. And so we had to make our own, and then we just made the whole thing directly, like the brain of the robot, rather than some type of engineered system. And there's different trade-offs, but it sort of is a lens by which you kind of look at everything afresh if you can just take the entire model and make it the brain of the robot.
Right. So tell us a little bit about what you're doing with Gen Zero. What, you've taken your learning, you're doing a new fun thing. What's the basics?
Yeah,
part of Gen Zero?
I think the most important thing about Gen Zero is it makes it so scaling in robotics in the very general purpose sense is now here. And what that means in terms of how we think about it is we have a very general purpose recipe. And to be honest, it doesn't even really necessarily matter too much what the x-axis is, other than like the x-axis is something that we can continually do more of, and the y-axis is some measure of how good the robots are, and we see that we can just continue to pour in more and more effort on that x-axis, and the y-axis continues to get better and better. That's a little bit of a generic phrasing, but importantly, like, we are able to take a model that is trained on very general purpose physical interaction data, and we train on more and more of it, and every single task that we are tracking continues to get better. And that is like a landmark type of moment, at least in terms of like relative to what we've seen before. There's been a lot of sort of attempts at making what you might call a foundation model for robotics. I think most of them, or I would say all of them today, the sort of main attempts have either been like some of the stuff we were talking about back at Google, where really the generalization amazingness comes from taking internet scale data and soaking that all in. Or you have more of kind of like a very kind of task specific paradigm, and you know, people might claim that it's general, but it always kind of seeps in there to how people like design tasks. And instead with Gen Zero, the way in which we scale pre-training is completely separated from any idea of how we think about any sort of particular task that we are solving. We continue to scale general purpose data. Every single task that we track continues to get better. This has been, it's a moment that we've been excited to share.
Right.
Yeah.
Now it's interesting, you showed a graph earlier in your presentation, and in the model that didn't have enough parameters, it stalled out.
It gave up,
It hit a wall and it gave up, right? The line stopped. So what's so different? Is it because you're able to incorporate so many more parameters to get past that critical function? Is there some other magic or secret sauce, or you just kind of broke through that tipping point, if you will?
In some ways, the concept there is very simple, but it is very profound, right? So if you go back to machine learning 101, like a decade ago, if your model looked like the validation loss was going up, you would call that overfitting, and you would say, okay, well, I need to somehow reduce my overfitting. And one way that you might try, it doesn't always work, but you might try to reduce the overfitting is to actually make the model smaller. And I forget the exact years, but it wasn't forever ago when the field started to understand this concept of double descent. And actually, it depends on the regime in which you're in, and it depends on how much data you have. And there are actually regimes where if you have enough data, well, then making your model actually much bigger it is actually much more effective at avoiding these sort of overfitting effects. And again, it's very simple, but actually having enough data, number one, in robotics, to see these types of effects, being in a data-rich regime within robotics, that has been a very challenging thing to attain. And then number two, actually having all of the model training all just right to create the conditions so that we can actually observe this, that has been tricky for us. And I would say, like, it wasn't like the first time we tried all of this, we sort of beautifully got this type of result. Right. It took a lot of iteration over a year from the team.
So one of the concepts talked about a lot here is synthetic data, because, you know, to train an LLM, there's lots of text out there. You know, there's a lot of data. For training robots, there isn't necessarily this giant corpus of data as there is of, say, language. Yep. So there's a whole concept of synthetic data. For the folks at home that don't understand what is synthetic data and how could synthetic data contribute to real data, explain how synthetic data is as a concept and how it's used in training these things.
So generically speaking, right, synthetic data is any data that is not, we would say, real. And for robotics, I think the most direct way to think about that is just any data that's kind of not from the real world. There's a lot of different ways that you can think at getting at synthetic data. I think kind of maybe the two main paradigms that people think about today are either from more of like a traditional simulator. There could be a better word than traditional. Shall we say like a physics-based simulator? Or you could use some type of a learned model of the world, call it a world model. And I think there's a lot of excitement around that as well. So
the concept for people that aren't as familiar, you build basically a digital world with digital attributes around the use case that you're trying to do. And then that way you can run a million kajillion, pick up the bottle and knock it to a different location within that world. Is that?
Yeah, that's a good way to think about it. For sure.
I can simulate the real world faster to get more trials to feed back to the machine. Is that basically what it is?
Yep. So for us, we haven't talked publicly about how we use synthetic data, but I would say that when we've presented Gen Zero, as we've talked about publicly now, like all of the data that is in Gen Zero that we've talked about, including the sheer amount of it, that is all real world data.
Right.
We have many different threads in synthetic, but we do really believe that real world data is essential.
Right.
Yeah.
And just to be clear, everyone here has talked about there's lots of different ways to train. There's lots of the data sources, real data, synthetic data, teleoperation, and use them all, right, as much as you can to get the most benefit out of them, where they
in the limit of, I think the thing is that focus is very important, right? So if human organizations operated such that focus could be infinitely sharded, or AKA like you could work in parallel on as many different things as you want as possible, then yeah, you would want every single data source you can. But I think the reality is that building a culture of a team where you are really pushing the frontier, it's helpful to have a certain amount of focus on particular bets that you are making as in terms of research and how you're pushing capabilities. And for us, yeah, we're primarily focused so far today on real data.
You've talked about the marginal cost of labor getting to zero. And I've heard that in other robotics talks, which is pretty interesting. Because I used to always say, right, if compute, networking, and storage were zero, what would you build? Because they're asymptotically approaching that, every single day. But now when you add agentic, you put it in something that can move and do things, the possibilities, especially compared to not that long ago, are pretty astounding, as evidenced by Waymos that are driving all around as we walk outside.
Waymos are amazing.
People to the airport.
Yeah. I mean, I do think that soundbite by itself, I think it's important to have the context that, like, perhaps a good way to think about it, over in more the LLM model providers, there's this concept that we eventually might be able to reach, intelligence too cheap to meter. And like, honestly, some of the models these days are amazing, especially the ones that are on the more sort of lower cost part of the frontier of capabilities. That primarily, does exist today for sort of limited levels of sort of LLM type intelligence. But I think a similar thing happening in the physical world, where of course I think the way in which these models will have impact in the world will be very gradual, and we see very much a humans and machines figuring out how to work together, and now you have a robot that can help you be more productive, get more things done, build more. But you can think of it as like the concept of just having a robot that could help you with almost any task that you could imagine, and have that be a very productive partner to amplify your productivity. We think that is very much a world in which we're headed. So.
Yeah. So just a final point before we wrap. You had one other kind of conceptual thing on that was really powerful, which is you want your robots to respond to stimuli, not necessarily just execute the skill. I mean, they're executing the skill, but you want them to have the flexibility to be able to respond and do things. What's kind of the essence of baking that in? Because you got to do that from training and design and everything, if that's kind of your holy grail, right?
Yeah, I mean, I hope ideally, most good robots need to react to stimuli. I think the ones that don't, you can, it depends on what your definition of a robot is, but I think having closed loop interaction with the world, aka you sense the world, you then take an action in response to sensing the world. That is kind of the core closed loop nature of what I would call is kind of the definition of a robot. So really figuring out how to make decisions given observations of the world, including different types of stimuli, I think that is the core of robotics in general.
Right.
And
the new robotics, right? Old robotics, when everyone looks at it, they see factory fullers, right? They see the.
A lot of robot arms. At the lowest level, they are closed loop, but a lot of robot arms that are in factories, for example, putting sheet metal together for cars. Yeah, they don't necessarily have anywhere close to the level of intelligence of responding to things like vision and other sensors that we might think when we think of sort of the future of robotics.
Right,
yeah,
right.
Very much the future of robotics is in being able to take in all these different multimodal inputs of multimodal sensing of the world and figure out how to not just like do a task, but really importantly, be able to generalize the types of skills that happen in one particular task across all the different tasks that you could have the robot think of doing. And like things like just like common sense in the world, like physically, like being able to recover from all the different edge cases that people run into, or being very robust to, like, no matter what happens, if somebody changes what the environment looks like, or the packaging changes, or some other notion of the task changes over time. Like, those are the types of things that we take for granted as being very easy, but are like the types of things that we need to solve for the next generation of robotics.
Right. How do you think about hallucinations, just in the context of LLMs, or just the model doing not quite exactly what you want, which is, one thing if it gives you a bad answer on your computer, it's a different thing if you say, take the glasses out of the dishwasher, and it gets a little bit more active.
I think in language models, we are all familiar with the concept of hallucinations, and I think the way that manifests for language models, right, is the language models just tells you something that they completely made up, and often does it very confidently, right?
Very confident.
I think the analogy for robotics, it has its own different flavor, but it would be like, you telling the robot to pick up the cup, and it just decides to do something else entirely different, like take your glasses off, or just not at all grokking what you asked it to do. So it maybe doesn't feel as much like lying, because it's not a verbal lie, so to speak, but it is kind of like a physical lie if the robot is just completely doing the wrong thing, or making up some type of an action that it really should not be taking. Yeah.
But at least you can see, right?
Yep,
I guess the difference is if you said clean up the dishes while I was out, and then it lied, and you got home they were.
Yeah, I mean, and I guess too, there's kind of two ways to avoid a hallucination for a language model, right? You can either say the correct thing, or you can say I don't know.
Right.
That's the other way to avoid hallucinations, is sort of recognize the limits.
Right.
And I think that is that's a very useful type of concept to have for physically acting robotics as well. Yeah.
Yes, I like that, because that's certainly not in all the word ones, that's for sure. They never come back with I don't know. All right, Pete. Well, exciting times, and you're right in the middle of it. So I think this is going to go so much faster than anybody. Again, I love Waymos just as an example, because everybody can see them, and I think it's been 14 years since Google launched the self-driving car project until they opened it up to any rider in San Francisco. So is that a long time or a short time? I don't know. Once it's here, it's here. I need to go to the airport. I can dial up the Waymo.
I think the thing with self-driving cars, right, is you really needed to solve the ability to take somebody on the public roads from point A to point B in order to make that quite a useful thing that gets started to ship in the world. And I think for the next generation of robotics, some of the, it is going to be a long journey in some ways for certain levels of just full capabilities. Yet at the same time, there's a lot of robots that can be shipped to do things that are not as dangerous to humans as driving on the public roads, right? So I think that there's just a lot of different types of robots, a lot of different types of use cases that people will want to use them for. It's not as much of a singular problem as self-driving has been.
Right. Great. Well, thanks a lot.
Great to chat with you.
All righty. Yeah. He's Pete. I'm Jeff. You're watching Humanoid Summit from Mountain View. Thanks for watching. See you next time. Take care.
Cool.
We're out. Cool. Thank you.